next session coming up is testing at the speed of DevOps. And we've got a couple of presenters here. We've got Neil Longmead from Lattics and Andre Madan from Parasoft. And Neil is heads a functional safety team at Lattics with responsibility for software testing, compliance, and automation, and has helped a lot of blue chip companies in US, Europe, and Asia do things like 26262, ASPICE, FDA 62304, etc. And Andre's been here at Parasoft for quite a few years now. I don't even remember how many, but he's a lead solution architect and, again, goes out and helps real customers do real stuff, you know, getting testing and certification in place. So they have a pretty interesting discussion here. And Andre, welcome, and I'm going to turn it over to you.
Hi, Arthur. Thank you very much. Can you hear me?
Yes.
All right. Perfect.
There we go. You should have the ball now.
Presenters, right. Woo. So Neil, are you on as well? Let's do something.
I am, yes. Can I just do an audio check? Can everyone hear me?
Yeah, we're up and running. All right, we don't have much time because we have a lot of materials to present. It's a joint presentation between Lattics and Parasoft. So why don't I just zip through the slides right now, and then we'll introduce the topics which we're going to be talking about. So the agenda here on the screen, you can all read it, but the point here is that Parasoft and Lattics have different functionalities, and combining them brings you almost complete coverage for your functional safety requirements that are outlined in documents that we're about to share with you. So you've seen some introduction of Parasoft in a nice video before during the break, or Arthur talked about Parasoft in the past in the beginning of the session. But so I'd like Neil to introduce a little bit of Lattics so you know what we are talking about here. Neil?
Awesome. Yes, thank you. Lattics is a software product aimed at understanding, visualizing your current software architecture insofar as visualizing dependencies, offering refactoring capabilities, and metrics that satisfy the functional safety standards with respect to architecture, such as ISO 26262. We can import C, C++, Java, C#, Python languages and visualize dependencies and the structure, reveal the structure of the code. We can also connect to Oracle databases and requirement systems such as JAMA, DAWS, Polarion, and visualize dependencies between safety domains. And we offer associated services around compliance, functional safety, and automating what we're about to show you through a DevOps pipeline.
All right, perfect. So Parasoft, we'll also be mentioning a lot and demoing live Parasoft C++ test. There are a lot of functionalities of the tool, but why does it stand out? Why do people use it and love it? Because it combines many functionalities, many features you need to comply with functional safety standards, such as static analysis that finds real issues. It also helps you to comply with coding standards that are required by those standards, required by those documents, right? But it's just a good thing to do, as Arthur and the panel discussed in the previous session. Unit testing is an effective technique to find issues that are could be very difficult to find at the system level. So it plays a role in when organizations want to shift left, because you can perform unit testing a lot earlier and integrate it in the DevOps pipelines like we're going to show you today. Where Parasoft stands out is our ability to execute unit tests both on the host and target and collect code coverage required for those functional safety standards. And then we also can combine with requirement traceability tools when we can map test cases to requirements and map requirements to those test cases. So coverage analysis, we can run independent coverage analysis, merge coverage across multiple testing domains such as system integration and unit level testing. And also we can display, as I mentioned, any level of code coverage required by those standards all the way up to the MCDC. All right, this slide is supposed to tell everybody that Neil and we are never going to make it as graphic designers in this life. So we come up with a slide and then some coloring. So anyways, so C++ test is a box here in the blue. What in essence, it does a lot more things than you've seen on the previous slide. But in essence, what the tool is meant to do is give people very stable and awesome capabilities to do static code analysis for safety and security standards. unit testing coverage, as I mentioned, requirements traceability. So that's in essence what C++ test product does. Lattice Architect, on the other hand, focuses on architecture. So it's a one level up from the domain of code, and where you can understand and define your architecture, you can control and monitor dependencies inside your architecture, and that gives you a path to run some interesting techniques such as build optimizations, understanding how you can combine certain functionalities together, dependencies together to isolate them so they can be built in isolation, hence optimizing and streamlining the build. Well, and together, those two technologies cover a lot for compliance requirements because, as you will see in a second, the functional safety standards, they do have clauses on architecture. So Lattice covers those and Parsoft covers the rest. And also combining those two and integrating them in DevOps workflow gives you the best of breed technology to be integrated into the CI/CD pipeline. All right. So something about, there are 20 years ago, the CI/CD automation, at least in the embedded world, was not a thing. And now we're seeing that organizations are moving into the modern CI/CD workflows. So just to kind of recap, because Neil will also recap it during his slide, during his demo, is that we have the current paradigm is like this. You want to run something locally, right? Then on a pull request, you check in your changes, and then something has to be displayed to the users within their ecosystem. So they look at GitLab or GitHub results, and you would like to present the data right at the fingertips where they see it right now. And then on every merge or successful maybe a final build, or maybe it's a weekly build, we'd like to see the trending and we'd like to see kind of overall conceptual results to be presented to management, to team leads. All right, so functional safety standards, this is where Neil has a lot more expertise than I am, because he is actually the person doing that in the trenches. Neil?
Thank you, Andre. Yeah, so both tools, as Andre has said, combine very nicely together to solve many problems in the functional safety domain, whether that's the avionics standard, DO-178C, or automotive, ISO 26262, or the FDA standard. They all require software testing at unit and integration level. They also require architecture compliance and traceability. But increasingly, we've seen the Lattice and Parsoft combination combine to support use cases such as freedom from interference, which is part of the ASIL ABCD, mixed mode criticality requirements for ISO 26262 Part 6. We've also seen use cases for cascading common fault analysis and using the data from Parsoft and Lattice together with the requirements tool, combining to show the traceability gaps and prove consistency for standards such as ASPICE. And in that as well, if you're performing activities such as the HARA, fault detection, FMEA analysis, and technical and safety functional concepts definition, then we have use cases and to solve some of the problems in those domains as well. Thank you, Andre. We go to the next slide.
Mm-hmm. All right.
What you see here is some of those clauses that Andre was talking about. This is taken straight from ISO 26262 Part 6. You can see what we've highlighted there in Table 4, things like control flow and data flow analysis, which is typically performed by Parsoft's C++ engine. Also some architectural requirements that Andre was referring to in Table 3, where we need to show, for example, appropriate hierarchical structure of the software components. And that's exactly what the Lattice DSM shows, together with coupling, cohesion, stability, connectedness metrics, which are all directly referenced in the ISO standard for automotive. The question that we're asking here is, can some of these requirements and tables be automatically fulfilled? Can we generate the artifacts which certification authorities like TÜV want to see automatically from the tool output in the context of a CI/CD pipeline for automation? And the answer, thankfully, is yes, thereby solving one of the biggest headaches of certification, in the sense that when anything changes, what do you regenerate? What do you have to retest? What do you have to recertify with those changes? So together with these tables, we have an automated documentation generation solution, which we're going to be pleased to show you shortly. And here's two tables, one from the Part 6 for automotive, ISO 26262 again, talking about the static analysis problems that need to be proven and clauses that need to be addressed. These checks typically are enabled in C++ test, for example, null pointers, dereferences, buffer overflows, data and control flow. And the paragraph below you see is taken from the FDA standard and guidelines for device industry, FDA 62304. For process verification for medical devices, and you can see that directly referencing the software architecture to be checked in the context of data flow, complexity, design, and traceability again. How do we do that? Well, we combine unit level, integration level, and architecture verification into one elegant solution and automated solution. So we combine data that comes from the unit testing, code coverage phases, requirements traceability domain, and static code analysis. We pull data from the two tools through APIs and make available through the automated reporting engine that we've developed together to generate a report that the TÜV has seen and signed off on and accepted as a suitable artifact for certifying to these very demanding functional safety standards.
All right. I think we're ready to flip to actually showing something cool, right?
Let's have a look.
All right. So, okay. So, no, wait. Need to give me a second. Fighting. All right, perfect. So where's the data coming from? I'll show you a couple of things about C++ test. It's not a whole demo. You'll see the whole demo later in the day today. But just kind of what Parasoft C++ test can do for you out of the box. So if you look at the built-in test configurations, there's quite a range of features and capabilities. Like, for example, we're talking about compliance today, and that's one of the themes. So, for example, if we're talking to, let's say, a customer who wants to insure your automotive product that is up to snuff with ISO 26262, we've got some test configurations here to run unit tests and collect code coverage, to collect the exact requirements, to fit with the exact requirements there. Or if you want to run static analysis for C, we recommend MISRA C 2012, which is probably the most up-to-date standard for C today. And then for C++, that's of course out as our C++ 14 guidelines. Just want to put a plug here that MISRA is coming out with new standards for C this summer, and Parasoft will be revealing something during the embedded world. So please come and see us in the embedded world. Now for security, we also have a wide array of out-of-the-box rule sets and capabilities to help you with scanning your application for potential security vulnerabilities. And you can always customize those rule sets, adding, removing some, right, or adding more from, let's say, flow analysis, right, like null pointer dereferencing, or maybe you pick something that has been a problem in the past, like handlers has been defined incorrectly and whatnot. All right, so those are the things that you can do with Parasoft for example, compliance. But I just want to highlight a couple more things here. For example, so we can run, as I mentioned before, in embedded systems. We can run on and off targets, so we support out of the box a wide range of embedded systems, as you can see here, and we have a generic configuration which you can customize to run pretty much on anything, which toolchain we support. Now, unit testing. Run unit tests, we can execute unit tests, as you can see, but before you execute unit tests, you'd like to maybe generate some unit tests or generate stubs, generate regression base. So there's quite a bit of functionality here out of the box to create yourself a stable unit testing stack, and then execute it and stub out the dependencies you need. All right, so those are out of the box test configurations. In reality, our interface, that's just one of the interfaces. That's an Eclipse-based interface. We also support Visual Studio Code and Visual Studio, and we can run from a command line. Long story short, you can see that we can import code coverage from just by running the application by itself. If you'd like to, let's say, generate some unit tests, this is easy by just right-clicking and then Parasoft, and then we can generate unit tests for that code. And in a matter of seconds, we got ourselves unit tests, right, and we can execute them right away. Same with executing static analysis. You can do that with just simple click of a button here. Once the results are all aggregated during CI/CD run, we can see aggregations of those results, and we can on various dashboards that we have. The product that you see right now is called DTP, Development Testing Platform, and it serves as a main reporting and analytics engine of Parasoft data, and not only Parasoft data. So for example, here on this screen, you see our compliance dashboard that is telling you everything you need to know about the MISRA compliance. What's the state in terms of like how many guidelines you violated, how many required guidelines you violated, mandatory guidelines you violated, and then it also helps you see overall state of your compliance here in a very nice report. So all of the rules are here and the story about those rules. For example, this is not compliant. You can drill in further and see what is exactly the problem there, and team leads can kind of look at it and assign, look at the documentation and assign somebody to look at it. If you are a manager or team lead and you have multiple projects under your wing, so the portfolio dashboard is really useful to see what is the compliance story and the overall quality story for all of your projects here. So it shows you severity of violations and then some testing data, some coverage data here. Okay. So, and also the last but not the least, you can combine a lot of data here in the custom dashboards, where you can see here I combine, let's say, LaTeX DSM, which you're about to see. I combined some coverage data, MISRA compliance data, and cyclomatic complexity data, testing data, all to just show you the compliance with ISO 26262. Okay. Now, with that, I want to turn it over back to Neil because his demo is a lot more interesting than this. All right, so we had to channel through Zoom because GoToWebinar has some issues on Linux. All right, Neil, back to you.
Thank you very much, Andre. So what you're seeing here, everybody, is a small embedded C++ library called ISO-AGlib. It's open source. It's freely available. And we've put this into a GitLab instance. This GitLab instance is called lpdop.com, which is the LaTeX Parasoft DevOps pipeline. It's the result of joint work between the companies LaTeX and Parasoft to innovate and produce what you're about to see. So this example is good. It's open source, as I say. It also has a defined architecture that someone's taken the time to specify. What tends to happen is people define the architecture very early and the picture doesn't change. Developers come and we change things. We turn things into spaghetti sometimes. We create bad dependencies. Clearly here, these gray modules should be optional components. There shouldn't be any dependencies between these gray modules. These colored modules here are mandatory parts of the system. So, and these subsystems provide to the layer above. And this layering should be strictly enforced. There should be no dependencies, for example, from driver to communication, because that would violate the architecture and disable this plug-and-play mentality in the delivery. So we have a GitLab system here. We have a pipeline that will do automated checks with LaTeX and Parasoft. The pipeline looks like this. As with most pipelines, we build the software first, then we launch those tests that Andre was just showing. I'm pleased the topic of security came up in the previous discussion with Arthur and the team. We can run a security analyzer alongside Parasoft to check the open source, and we do that with OpenSSL in this example. And then we can do some architectural analysis and checks here. We also have a traceability engine that we can use to link to a requirements tool if you use that, such as Doors or Jammer. And then this phase is the most important, the documentation generation, when things change. And it's fully integrated into the Git workflow. It works with GitHub, GitLab, Bitbucket. And so what we do is we end up sending all the data to the merge request. But firstly, let's look at the architecture as it is in the code. And that's what we use LaTeX for. LaTeX takes the output from Parasoft. So if you have Parasoft in your toolchain already, you don't need to do any extra work to produce this visualization. We read directly from the full C++ parse tree that the EDG front end within PowerSoft C++ test can produce. And what you're seeing here is the relationships between all the components. You read down the column to see what a component is using, and you read across a row to see what a component is used by. And we highlight here some architectural issues. Firstly, it has put COM at the top of the system, so that's pretty close to this diagram. But there are other elements like utils which are not present in the diagram in the architecture. We also have lower level components such as util, which should be a consumer, using things high up in the architecture, which is creating this cyclicality that you see here. And the impact of a change is therefore higher than it should be. If you look specifically at this util level, you can see the util funcs is heavily used. You can see which components are using that above in the architecture. And if I was to make a change to the system, I can run an impact report to calculate the transitive closure, the complete effect of changing a component on the whole system. So the idea of this is that we now enable change-based testing because the impact report shows exactly which elements are affected if we change that file. We can then pass that to the pipeline, thereby solving an amazingly difficult problem, which is we have 1 million unit tests in C++ tests, for example. You make a change, which tests need to be rerun? And because of the complexity of embedded systems is growing exponentially, we cannot feasibly rerun every test with every branch or with every change. Now we have a change-based testing approach where we can calculate the impact of a change using this architectural method. We also said these modules should be independent, so now we can actually specify that these independent modules should be independent subsystems, and we can create different rules that enforce that in the architecture and in the build. Now you can see there were already violations because I said these two components should be decoupled, however they are coupled and they are using each other, so that would count as a violation. We can also define additional structure and use this for refactoring. We could create a new system here for mandatory, for example, and it will recalculate the dependencies. We can move things around and visualize the new structure and arrange the structure by usage instead of by directory structure. We could do a functional view of the architecture instead of a directory and file level view. And then for functional safety, we have the architectural metrics such as stability, cyclicality, complexity, connectedness that the functional safety standards call out. For example, as the table was showing from Andre earlier, hierarchical structure of software components, the two have agreed that the DSM is exactly the correct representation of this clause to satisfy for the automotive standard, as is the cohesion and coupling reports. So I've defined an architecture. I've found some issues in my architecture. For the first time, I can visualize what my architecture looks like, and I've set some rules up. I'm going to show you what happens if I make a breaking change now to my util funcs. So I have in C++ test a suite of test cases at the unit level, which give me full coverage, as you can see here from the coverage view, and my 3 test cases for this simple function in utilfuncs.cpp. So now I'm going to simulate what a developer would do, make some changes, and what we're going to see is this pipeline running automatically to answer the question, is my code ready to merge? Has it achieved the correct functional safety standard? And the way, so here's my unit. I'm just going to open that, create a branch inside GitLab and make a change. And if I go to the function here, I'm going to break it, so introduce a mutation. This should cause those 3 unit tests to fail, or you'd hope so. And I think Arthur was mentioning OpenSSL. I'm going to create a dependency to OpenSSL. So that will trigger some security and open source scanning. And here I'm going to create a bad dependency to a part of the architecture that breaks my rules, that utils should not be using COM. And then I'm going to introduce a new function with some AutoZar and MISRA issues, and also no tests. So I'm not going to commit any tests. So obviously there's no code coverage for this new code. I would expect my coverage to drop. And we've configured a gateway, a quality gateway, that if code coverage drops, then the merge request is not accepted. So you can then make sure that you're not introducing any more technical debt into your development. This is a big problem in the industry, as you know. People develop code, technical debt comes in, that quality backlog isn't paid. So in the interest of time, I'll jump to a merge request that I already did earlier. Firstly, we put all of the data from PowerSoft, C++ test into GitLab, into the merge request. This is exactly the place where I need to be to decide whether I'm using this, whether I'm going to merge this code into my master branch or not. And you can see, firstly, the delta DSM. This is the difference between my branch here and the master branch. I've introduced an architectural regression. I've made the architecture worse. I've decreased stability. And you can see that in the heat map now. We have just make this bigger, we have pulled the data from PowerSoft in terms of the coverage data, the static analysis violations for AutoZAR, CERT, and MISRA. Now you can see them for the first time through the prism of the architecture. So you see where I'm red, and particularly the function I've just changed has all gone red because I've broken the coverage, I've decreased the coverage, and my impact of the changes in this branch is also very high. So this is what LaTeX is using to decide whether to rerun a test. You see my code quality has degraded, and what you see here is all the PowerSoft C++ MISRA violations directly in the merge request inside the CD pipeline. I can jump, I can see the violation at an instant, which is really good. And if I go then back to the merge request, I see the test results as well from C++ test coming in, and you can see my tests have failed. Let me just go to the report there. There we go. You can see that exactly those tests in the function that I changed have regressed. So this is not a great code change. I've made the quality worse. My coverage has also dropped, but I still get a compliance report at the end. I still have the mappings of which parts of the functional safety standard were met by this code. And this is a complete report generated in conjunction with TÜV. I satisfy these clauses. I don't have any of these issues. My suppression report coming from the PowerSoft rules, the AutoZAR rules that are mapped, the architectural visualization, plus the heat map, and then the code coverage reports at the end. Everything at the click of a button is now available. I even have a system where I could directly upload that to the TÜV repository for the project I'm working on, and they would receive that automatically, the updated certification artifacts. This is also implementing control flow, data flow analysis, and data flow coupling, which I don't have time to talk about, but that's fully integrated as part of this compliance for automotive. I also have a medical version of this pipeline that's based on the FDA standard. So we've got some DevOps code that will put a medical documentation together. All of this code is done as infrastructure as code using YAML, and we've containerized the PowerSoft. I think the gentleman from VW earlier, Stefan, was talking about using Docker, so we have a full Docker enablement of the containers, and also we have the container architecture and topology for PowerSoft and LaTeX together combining to produce that output report. So everything is completely integrated, seamlessly integrated, and then as I finish, you can also see we can put the security issues that we found directly into the backlog of the issue backlog found by the tools, so that's into our issue and backlog management in GitLab or Jira or Jammer. And the traceability report can also be generated from the CI/CD pipeline. So there you have it. You have integrated unit testing, code coverage. Back on the desktop, you can also see, if I click now on the desktop view, this data is pulled from the server. I can now visualize my DSM in the context of AutoZAR. So now I see exactly where my AutoZAR violations are in the architecture. I can also see the coverage views and see, for example, where I'm missing decision coverage in this case, where I need to strengthen my coverage and testing work. All of that is mapped into the architecture and the resulting heat map. So I'm conscious of time. I'm going to hand back to Andre to complete this short presentation and demonstration. Thank you,
All
Andrew.
right, thanks, Neil. Just 30 seconds from me. As you can see that combining the strength of Parasoft and Lattice and then the CI/CD artifacts that Neil was showing, you can quickly get yourself to compliance with these in the context of DevOps. So a couple of bullets here, what's important. Of course, functional safety standards, they all have clauses about architecture. They all have something about code quality like unit testing and making sure that you run static analysis. So everybody now requires that. But now we're adding all of that into a DevOps pipeline, and Lattice calls it DocOps. So what Neil was showing you the report at the end. With that, I think we are done. Thank you very much for watching the joint presentation.